Let me bring on Mads Torgerson. He's the C Sharp language designer, and Dustin Campbell. He's the principal software engineer, and they're going to tell us what's new in C Sharp. Take it away, Mads and Dustin.
Sure. Thanks for having us here. Great to see all you folks out there. As Jeff mentioned, I do C Sharp language design, and so does my buddy here, Dustin. We can't hear you, Dustin. You're muted.
Dustin after like 8 months, you think I'd have this down, right? Well, yeah. So I'm Dustin Campbell. I'm an engineer, an architect working on .NET tooling, and I also help design C Sharp.
So we decided to have a bunch of really exciting slides for you today. Dustin, can you run the slides?
Yeah, sure. Let's do them. So we've got what's new in C Sharp. That's us, and then there's this one. That's very cool.
Let's go have a look at C Sharp.
Okay. So that's pretty much the slides, right?
Yep.
All right. So let's go over to code. What do we got here? Well, we've got a simple program. It's our typical program. We do these kinds of programs all the time. Unfortunately, Mads, we've added to the end of this program, and now I can't see the closing brace, and it upsets me. It's just long.
Yeah.
And
as a PM, I'm deeply disturbed when my whole program doesn't fit on a screen.
I mean, it's generally been a problem with C Sharp, from heritage and thing, where the language comes from, that there's a lot of ceremony in the language. That's the way it is with computer programs. You got to tell them everything to go do. And sometimes you just want to express yourself. I mean, so I've got to have a class and a main function just to get this working, right? It'd be really nice if I didn't have to do that.
Yeah, you kind of have to wade through to find the main program. Imagine being new coming to C Sharp, which all of us was at some point. Now, how do I find where's my program? Where do I start reading the code?
Yeah, the first thing you learn in C Sharp is static void main. This is what this, you have to go learn. So it'd be great if we could just remove these. So I'll go ahead and do that, okay? We'll see what happens. There's going to be compiler errors, of course, but there's not. And that's really nice.
Because now you can write statements at the top level of you choose one of your files. If that's your program, you just start writing your main program right there after the usings, before the classes and namespace.
Before the classes. So there's some rules here. Like I can't write things down here. I mean, if I could write line, that's going to give me an error, right? Because top level statements must precede namespace and type declarations. So yes, I can only write it ahead of my classes. So right in here, this is kind of the body of my main method. I guess, well, tell me about this. We've got a function here at the top level as well.
Yeah, but that's just like where it was before. It was a local function inside of the main method, and it's still just a local function. Like we didn't take the step, at least in C# 9, to say, you know what, you can define top level functions that are, say, public and can be called from anywhere. So this is still like only something that can be called from within the program. That's something we might do another day. But for C# 9, it was really important just to have the simplicity of your program being right there at the top of the file. And any other things we could do here, we can sort of see if there's a demand for it down the line.
Awesome. So so the program we have here, this is now it's very succinct and it's nice and I like that. The program we have here, we've got a person class. This is our typical demo fodder, right? We got a person class. We're literally creating out of thin air, out of nothingness, out of the vapor and the ether, Scott Hunter. But the thing I love this syntax, right? I love the object initializer syntax where I call the constructor and I set some properties. But what I dislike about this is that means if I want to use this nice kind of initialization syntax, I have to have, public mutable properties, right? And so that means that some nefarious person, right? I don't know who, but some nefarious person could very easily come up and do something like, I don't know, this, right? And I can't do anything about it. I mean, I can't express in my program, well, don't do this. I could throw an exception, in the setter or something like that, but it doesn't help me guide the user that no, they can't do that.
Right. I mean, so with the as the years have gone by, immutable programming has become more and more prominent. And you can certainly make the person class immutable. You can just remove the setters. We did add getter only auto properties at some point. But the problem with that, if you try doing that, is that now you can't use object initializers either.
Right. Now I get an error here because I can't assign in this. Yeah.
And so what we found in C#9 is you sort of need a middle ground. You need, in order for object initializers and immutability to work together, you need a version of the setter that only works during initialization. And that's what we call init only properties, or the init setter.
So like this, right?
Yeah. You put that on the last name, you will see that the right thing happens, right? We can initialize with an object initializer because there is a setter, but it's only available, it's only allowed to call it until that end curly of the object initializer. And then from then on, you can't mutate the object. So you can now use object initializers to initialize an immutable object graph.
In a way, this is C# kind of, accepting that initialization, there is more initialization to an object that happens beyond construction, right? And kind of really embracing that, and not just making it a sleight of hand, but really embedding it into the language that these are things that you don't want to change afterwards, but you still want to use nice syntax. You shouldn't be penalized for doing so.
Right.
I love it. But we can't do that anymore. Okay. Cool.
Great.
Great.
So, but now we run into another thing, which is that when you are working with immutable objects, you sort of, there's still mutation in the world, and you still want to express that things evolve, right? And there are these patterns out there, including in our own Roslyn compiler, for what we call non-destructive mutation, where the object no longer sort of represents the real world entity in a strong way, that it has identity and state that evolves over time, but that you produce a new record of the state of the world every time something changes.
So it's so-called like non-destructive mutation, right? Or yes, where I'm going to mutate the object, but I'm not going to destroy the original object. I'm going to get a copy with my changes in it. But to do that, we don't have any functionality for that. In Roslyn, we did that by laboriously adding tons of with methods that you could then say, okay, like on here, we'd add a with method to say with first name, with last name, that sort of thing. And it was laborious. We did this all over the place. We ended up using source code generators to make it so that we didn't go insane.
You didn't have to write your own code. So this is where the sort of classic object-oriented programming fights you every step of the way. And what we said was, well, let's embrace this. Let's say there are actually objects that are more like values, and we do that with what we call records. So C# introduces the notion of a record, which is a class, but a class that has been enhanced or augmented to have value-like behavior, to more represent a value and less represent a stateful, encapsulated, strongly identified entity, right? So.
Well, though one of the first problems I see is I've got a compiler error because only records may inherit from records, right? So once you step into this world, you're in this world, so to speak. So this also now must become a record. I've kind of carved off a part of my hierarchy, my class hierarchy, and now these are records, and they participate in this universe. And then
from here on down, everything's records. Yeah,
the records.
So what does it mean to be a record? Well, it means we can go back to the Hanselman thing and say, well, we can't change this thing, but we can create another object that's just like Scott Hunter.
Yeah, well, just like, but I'm not going to make any. I'm just not going to say anything else. But with a different last name.
But with a different last name. Yeah.
Right.
So no semicolon there.
Oh, sorry, my bad. My mistake.
So what we have here is a new kind of expression called a with expression, and it takes an existing object and then puts an object initializer, copies it, and then puts an object initializer on top of that copy, right? So we could put more properties in there if we wanted to. It is really an object initializer between the curlies there in the with expression, but instead of initializing a freshly created object from a constructor, it initializes one that was freshly created by copying the old one.
I see. And so now I could print this I'm actually going to run the program for the first time here.
Oh, yeah. No, yeah,
You can
programs
see
can
it,
do that.
see it run. Yeah. So,
Yeah.
and we see that there are in fact 2 objects that we're displaying. I could
Yeah.
also, one thing I really like about, I've noticed about records as well, is that we get a really nice toString in there as well, a really
Mhm.
nice toString implementation
Yep.
that'll
Yeah.
print our properties and the type of the class. So I really don't need that display person anymore for the purposes of this demo. We can just write these guys to the console. I mean, a normal class isn't going to print its properties, right? It's just going to print its type name by default unless you override toString, but we provide a decent implementation so I can get that kind of thing as well.
Uh-huh.
Do like that. Do
Yeah,
like
that
that a
is
lot.
nice. And so we really got some value semantics here, including that there's this copying built in to the with expression. That's a copy by value. It's a shallow copy, just like you have with the record. With structs already today in the language. So structs, when you just assign them, they just do a copy of the whole struct value, but it's a shallow copy. If there are any references in there, you don't recursively copy what's at the end of that reference. And that's exactly the same for records. So they have that kind of value semantics. But another important thing to being a value here is that you have value equality, which structs also already have in the language. And so that shallow equality semantics, so that value equality semantics of structs is now also in records.
Okay, so if I understand you, and of course I do because we're presenting, but I could take the other person, right, the one with the handsome last name, and I could create another person from that. This is totally Inception here, and I could give him back the name Hunter. That is still a new object, right?
Yes.
But it has value semantics. So meaning that it's the parts of the thing that decide whether it's equal or not with another thing. So if I say then that the person, the very first person we created up here that was Scott Hunter, and the new one I just created that should also be called Scott Hunter, they should show as equal, right? But we said that they're different objects. So if I check them for reference equality, that should be false, right? So if I run this again, I'll see that indeed equals is true and reference equals is false.
Yeah,
that's
exactly
pretty cool.
right.
What? Oh, sorry.
Go ahead.
I was just going to ask, what happens if they're students, right? This is something I've been always a little worrisome about. Is that what happens if this is a student, and down here that's fine, but if I change this so that statically I'm dealing with person objects, right? So really down here it's a person,
right?
But at runtime it's a student. So how does this kind of play out? How does this work?
Yeah, I mean, one of the reasons that we have been talking about records for almost a decade in C#, but we only got around to doing them now, is to figure out to make sure we got the interplay, the crossover effects between inheritance and value semantics right. And so that's a very astute question. We want to respect the runtime type always of the record. So even though the compiler can't see that there's a student here where it does the equality and so on, both the copying that happens in the with expression and the equality that happens in the equals call, they actually work on the actual runtime types of the objects. So when you do a with expression on the student, even if you didn't know at that point in the program that it was a student, you do get a new student, and you get all the student-specific data copied over as well.
Right,
so
because
this
is a person. This is a student. I don't have the other property because I'm statically a person right now, right? So, but it manages to keep that studentness as part of it.
Yes. So if you had if you set the is it a GPA that the student has?
Yeah, I think it's
you
GPA.
Set that last property in that first object initializer. That gets copied over to Henselman as well. He gets the same GPA. So
what to do here. I feel like my job is in question here. We'll go like a 4.5. Like he was an overachiever. Yeah.
And also when we then do the equality, it actually checks to see that they're the same kind of record at runtime, and that all those hidden properties also are equal. So and we make sure that that's symmetric and so on. And we make sure that not just the equals method, but also equals is redefined, is overloaded on records automatically that they implement I equality of T and so on. So really do this equality thing all out.
Oh, so just running it one more time,
Mm-hmm.
we'll see that indeed it is a student, and they both now have GPAs of 4.5, even though I couldn't change it on the second one. And again, the equality that we're talking about, the value equality, holds true. That's awesome.
Yeah. So yeah, that's sort of the core machinery of records right there. Oh, go ahead.
No, I was just going to ask. So this is cool, and I'm creating with object initializers. There are other ways to create objects, like all other types we use in C# allow for constructors, right? Can I use constructors in records then?
Absolutely. And not only, I mean, records are really just classes, right? You can do pretty much anything you can do in classes, you can still do in records, except inherit from other classes, or
that aren't records. Yeah. Well, it's just like classes and structs, right? I can't inherit a class from a struct, right? It's a different kind of thing.
Yeah. So you can create your own constructors, but we figured, since records are really values, and it's a very, very common case that they will just have the data that is exposed on their as public properties. They will almost certainly be immutable. And so whenever you have a constructor there, we are going to assume oh, we got some nice Blazor code in the
that wasn't me.
There we are.
I have no idea how to do that demo.
Here, instead of just declaring a constructor inside of person, which you can totally do, you can actually declare the constructor parameters directly on the class itself. And when you do that, that will even generate corresponding members.
It generates the members for you. So
if you don't write them yourself, it will generate them for you. So you can even replace the empty body with a semicolon here. And
now,
that way
go ahead. Finish up.
Yeah. And similar to student, if you wanted to, right? You could take more parameters and pass them through.
Yeah, that's what I was going to say. I mean, this kind of then gets you into the constructor thing, where you now have to, all the downstream classes have to have constructors, and they have to deal with the constructor that's on the base class. And so in this case, we can pass in GPA, and we can initialize it just like we did before. But I need to pass these down, so we've got syntax here right on the base.
Yeah.
Yeah. There we go.
So it looks like we have a question or two on this that we could quickly take.
Okay.
I saw that there were some questions.
Hey guys, yeah, I've got a couple questions coming in from folks in the community.
Sure.
All right. Kyle the Coder has a question here. Let me put this up, and we'll take a look. Kyle asks, can C#9 make anonymous types into records? And if so, can you use a with call on them?
Not in
C#9. Just talking about, not in C#9. Something we were just talking about. Yeah.
Yeah. I mean, we are sort of, in C#10, we are sort of doing the remainder of the work to take anonymous types and sort of retcon them retroactively, consider them to be anonymous records, which means that they also get with capabilities in C#10. So that's coming up soon. That's a very, very good question, because they have exactly that same value equality and so on. They just like with capabilities.
And that actually leads into another good question that I want to touch on here from Cecil. Wait a sec. It's moved things on me here. There we go. How should developers think about choosing between records, classes, and structs?
Yes. So if you have if you have data structures where things point to other things, you need a reference type. And so in many ways, records solve the problem that I want to be value oriented by default, but structs don't cut it for me, because they don't. I mean, you can't really have data structures with structs pointing to structs. So you do need allocated reference types, and you need hierarchies to describe your data model, like inheritance and so on. Then you really want classes, but you want the value semantics. So that's how you should think about it. Do I need an object graph? Then it's a reference type. Should it be an ordinary class or should it be a record? Well, that depends. Am I describing primarily values and probably working immutably with those, or am I primarily doing classic object-oriented programming with mutable state that's encapsulated? That's then between the classes and records.
Cool. Very cool. I just want to have one final question here. It's updating and not. There we go. Can we use emojis as variable names?
I think we rejected that just once more.
We did.
Yeah, it comes out every so
I came through C# Lang repo and we said, nah.
All right, guys, I'll let you get back to it.
We get bigger fish to fry, even if you can't put a fried fish in there. So, Dustin, we have lots of other things in C# 9. We're not going to show them all today.
No, we aren't. I do want to show one more thing that I think is critical for records, and that's once you've got construction in here, and once you're in this kind of positional form, we know how to construct one. We also know how to deconstruct it, right? As
that's
well,
true. Yes.
which is super useful. So just like we have with tuples, you can then take these things and deconstruct them once they have a constructor. Otherwise, we don't know what order things go in, and we can't. But yeah, you can deconstruct it and then into variables, and then use those variables in your code. So that was the last thing I wanted to show on that.
Cool.
But we do have other things in C# 9. Do you want to talk about some patterns?
Let's take a quick look at patterns.
Yeah.
I think we can spend a couple minutes on those.
We always talk about patterns. We always are tweaking these and making them better and better.
Yeah,
introduced with C# 7, improved in C# 8, and now improved again in C# 9.
Yeah.
So
this here is actually we've been using this demo for a long time, and it's the tutorial in our docs pages for pattern matching. This is the C# 8 state of it, if you will.
Yeah, this is the state we left it last year. I think we did it for C# 8. So what's new here? Well, there's a couple of things new. First of all, one of the things that's kind of annoying is that when you just want to match against a type, you have to include a discard, right? Or you did have to include a discard. Now you don't have to. In fact, we'll tell you not to, which is kind of convenient. We'll tell you that is an unnecessary discard now. It was there for, again, just kind of some ceremony in our rules, and we've tweaked those rules, so that's no longer necessary. But what else can we do? This has gotten.
Yeah, you got those when clauses.
Yeah. Yes, these guys
in a delivery truck, for instance, and this we figured this whole comparing something to a constant, that really deserves its own pattern rather than you going into a Boolean expression.
Right.
So we could instead take the delivery truck and then apply a nested switch to its gross weight class.
A nested switch. So again, like the thing below, like we've got below, but a nested switch inside of here.
Yeah, you have to say switch.
Switch. Yeah, I know. I'm not very good at this language.
And not the.
Don't use this language.
There you go.
There we go. Not the arrow. Well, in C# these days, that double arrow is used for so many things that I just type it and usually it's correct. It's correct.
But now you can simply grab those things and put them in, and the greater than 5,000 is a pattern in C# 9. Yes. So you can say greater than something, less than something, as long as it's a constant, and they now qualify for their own pattern. But now you kind of want to, that last one there, you're sort of lucky that you can express it as the fallback, which is really like an interval that's limited on both ends. I see. So you could express that directly. Like it'd be really nice greater than or equal order. Right? Yeah, exactly.
Because I want to put this above that because it's less than, and then there's the greater case. But this one, like you say, it sticks in the middle. But I can't do this because it subsumes. Yeah.
Exactly. You want to say it's greater than or equal to 3,000.
Right.
But you also want to say, and it's less than or equal to 5,000. And now you can, because of that and keyword, you can say and, or, and not between patterns and combine them in that fashion.
Okay.
Including that, if I want to show a last thing, we should probably sign off here, but if you want to show a last thing, you could say not null there, for instance. Null is a pattern. But now you can put not in front of it, and finally you have the pattern for not being null.
Right, and I could still do one that's a little more correct because I could only throw one exception before, right?
Yeah.
And now I can throw the correct exception when it's not null, and the correct and argument null exception when it is null. That's cool.
So yeah, that's what we have on patterns. For other things, you should go and read the docs. There's lots of docs on new. There's a section on new C# language features that you should go and check out. And you can play with this stuff right now, as with all the other .NET 5 Wave stuff.
Excellent.
And is there one last question on this?
Yeah, one more question.
Or do you want to kick us off and get back on schedule? It's up to you.
It's up to you, Jeff. Cameron.
The world relies
gosh.
on you.
I think we should move on to the next one. We've got I think we covered some really good questions there around records. There's a couple questions regarding more ASP.NET can use records as parameters to ASP.NET controllers. I see from Roger Farr out there.
Well, you can use records for anything you can use classes for. I can't tell you on the top off the top of my head if it's the right thing to do, but if you can use classes, you can use records generally. I mean, there might be some reflection things where things get awkward, but generally, they really do just generate classes under the hood.
Okay.
So if you want those semantics that records give you, use them.
Yeah, those records with those positional constructors at the very top, those are still generating the public init properties under the bottom, which should be able to pass to anything that accepted something that looked like that before.
Yeah. Okay. Let me go then. Let me just one more question while I have you here. I'll bring this up again, and here it is. A question from David McCarter asks, does the new record type serialize just like any other type?
Yeah.
Yes, it does. It does. Because I mean, under the hood, it's generating name. I mean, all the names are generated as they were, and it does the same thing. And the fact that maybe the field under the hood might be read only, the serializer allows for that, and so it does work.
Yeah, the serializer already breaks.
Yeah, already breaks
read onlyness, and we let it keep breaking read onlyness. Yeah. We didn't want to. I mean, we didn't want to gratuitously ruin a whole bunch of scenarios that are working today just because you switched to record.
Right.
So the same sort of backdoor to slamming things into read only fields is still there for records.
I don't know what you're talking about. That can't be.
Just being honest here.
Okay. Well, I think that's all the time we have, fellas. Thank you so much for bringing us up to speed on some of the cool new features in C# 9.
Absolutely.
Thanks. It was a pleasure. Have fun, everyone.
I'm delighted.
Oh, my gosh. We'll catch you next time.